there, and thanks for joining me for this video. FNIRSI, a long-time channel collaborator, sent me for review a new oscilloscope that I've been testing for quite some time now. And I'm talking about the new DSO152. This oscilloscope seems to be the successor of the loved DSO150, but with an awesome new case and with a sampling rate of 2.5 megasamples per second. It is a good-looking fellow, but the ninja electronics engineers call these devices toy oscilloscopes and normally define them as junk. Not my opinion. I think there is always the right tool for your needs and your wallet, but in reality, is this something that you should consider buying? Bear with me and create your own opinion during the review. I have mine already, and I will tell you in the end. Now the usual disclaimer to inform you that this item was sent by FNIRSI for review free of charge for me, and I didn't receive any payment from FNIRSI for making this video. Let me thank them anyway for the consideration and for sending this item for review, and I want to thank you, all of you, that use the channel affiliate links in the screen or the channel affiliate product link in the description before paying your purchases on AliExpress or Amazon, sponsoring this way the channel without spending a cent more. You rock! Without further ado, let's see this small scope working. Okay, so as usual, let's start by the unboxing. This is the box that arrived to me from the DSO152. As you can see, this is a retail box. It has already this hole to put on shelves to sell on electronic stores or stuff like that. So they are really improving the packaging. We can say here that they say that we have 800 voltage peak to peak and 200 kilohertz of maximum bandwidth. Yeah, some stuff firmware upgrade, and yeah, it seems sweet. Let's go and see what is delivered with this. Okay, it has the, sorry, I didn't saw, it had a sticker there. So let's see what is delivered. First of all, we have this user manual. Okay, looks good. No color, but a lot of information, and seems fairly enough organized. Yeah, nice work with this. We have the diagrams. This is Portuguese. Haha, so cool. Well, but I will use the English for everyone. So we have diagrams, it's clearly explained. Very good, nice work. So in terms of what is delivered, we have one of these MCX, I think, connectors. And this is a sleeve for transportation. Well, but my hand will not be able to enter this if it was to put in the wrist like it is normal. So yeah, and we have a USB Type-C cable for charging. Okay, and another thing, because I already opened this box and it was delivered, it came in a big box with I can show you, it came in this big box with other things for review. So yeah, and in the box it came also with a probe, and this probably is, I'm almost sure it is, the 16100 100 megahertz probe. With the probe comes already also this adapter MCX to BNC. So yeah, pretty cool. We have the normal screwdriver for probe compensation and the color rings and everything. So you have a probe also delivered with this. The device, let's see. Okay, so this is not rubber, this is totally plastic, It has a very nice finishing in terms of what is delivered. I think, yeah, it has a stand also. We have on the top the output for square wave for compensation. We have here a control button and the output, the MCX output for connecting the probe. We have a buttons, and the buttons, those are rubber, pretty easy to press, and we have, I think, yeah, the power button here in yellow. In the bottom we have the hole for connecting this wrist thingy, and on the left we have the connection for the USB Type-C charger, and we have two holes. I believe the one should be the reset and the other one should be the light when charging. So yeah, I will see that ahead. Okay, in terms of first impressions, that's it. It's pretty compact, really compact, so pretty easy to take to anywhere. If you need it, just grab it in the pocket. Okay, so I have already this setup for showing how it operates. I have put this little, I don't know how to call it, it's not stereophone, so this protection, just to give the right inclination so you don't have reflection while recording. I have everything set up, so let's power this on. Let's do that. Okay. So yeah, the screen has a very nice image. Yeah, really good. This is a very simple device, but with a very nice screen. In terms of information on the screen, let me grab my pointing thing. I have here the amplitude in this area. We have in here the probe attenuation. Right now it's 1 time. And we have the 20 microseconds here in the time division. Also the coupling and the run indication and stop, like this. So we have the auto, like the name says, is to auto configure everything. We have the mode, and in the mode, if you press 1 time, it will change the triggering. Okay, and if you long press the mode, it will change the edge, so the slope is changing like that. We have also the normal up and down buttons. Right now it's not running, and if you, other than the run stop here, if you long press, just like before in the other devices, for a long press it will show and hide the information on the screen. So pretty basic to operate. This device has another cool button, that's this one, and if you press this button for some seconds, it will open the calibration menu. To calibrate, just press run. It's a quick process, as you can see. It doesn't take much time to do the calibration, and the button can go up to the right or to the left and select also. So you can use it to change the menu. As you can see, it's going around the several options that we have, and if you want to change it, you can, for example, to increase or decrease the amplitude, you can use these buttons up and down. And yeah, times 10 and times 1. And let's go to the minimum, and the minimum time division, it's 10 microseconds. Okay, AC, DC, and that's pretty much. We have here the triggering that we can change. I think we should. Okay, yeah, we can. So we can change the triggering. So let's connect this to my function generator and test the bandwidth. But before, I will, let me just insert this in here. Okay, it's not, now it is. Okay, it took me a little force to do that. So before that, let's connect this, and we will do a probe calibration. As you can see right now, we have already on the screen, it's doing auto. Okay, we have already on the screen the square wave. As I told you before, we can take this and increase a bit. Let's take the information out of the screen so we can have a bigger, yeah, like this. And I want also to, let's move it, increase, yeah. So right now we can see overcompensated or undercompensated, I never know which one. But to compensate this, you just insert your wrench here and rotate until you have a perfect 90-degree angle like this. Okay, I think that's it. Let me take this out, and I will take this protection out also. And using this adapter, I will connect this to my function generator. Okay, and that's it. I have my function generator already outputting a 10 Hz square wave. Let's see how it's handled. The auto takes a little bit to complete. I think the DSO152, it was faster. And my bad, I think I saw something in the user manual saying that we should have at least a 50 Hz. Let's put this in one 50 Hz square wave to do the auto. So let's try again. Okay, so we have I have a very high VPP. I'm gonna put this at 2.5 volts VPP. Yeah, like this. So here we have it. Let's increase this and also stabilize the square wave with the trigger and increase a bit. Yeah, so it seems to work well. We have a 100 Hz square wave. The user manual does mention, let me see, so the user manual does mention that below 45 Hz cannot be calibrated correctly. So my bad, I started with a 10 Hz square wave, sine wave, but with 100 Hz, here we have it. So let's take this to 1 kilohertz and see if, for example, the auto will handle it better. Auto, yeah, the auto takes a bit to get there. Okay, we got it. So I will change the amplitude to 5 volts PPP. Yeah, and let's increase here. Yeah, seems very nice. How about a square wave? Yeah, a square wave, completely 90-degree angles. Okay, back to the sine wave. Let's take this to it's 1 kilohertz. So the maximum of the device is 200 kilohertz. So I will take it now to 50 kilohertz. Auto again. The auto takes a bit to get there, but yeah, it gets there. And let's take it to half of the maximum bandwidth. This device has 2.5 megasamples per second. That's a lot more than the 138 and the equal oscilloscope. So in terms of line, you can see that it's much better. Let me decrease this a bit. Okay, not bad. Okay, so let me go and increase this to 200 megahertz already, and in 200, no, not megahertz, kilohertz. In 200 kilohertz we have the signal. It's not bad to be honest, but the problem is we cannot increase the time division anymore, so it's all so together that you cannot have a clear identification. But in terms of working and in terms of representation, it's stable enough. It's better than the other ones, but the problem is that we should take this a little more, like 5 microseconds or stuff like that. Yeah, let me see if changing the amplitude to 1 volt VPP will matter. Nope, it will not help anything. Okay, in terms of stability and usage of the signal, it's okay. If you are starting in electronics, this will be an awesome tool to have for a fair price. Okay, so in terms of bandwidth, let me just put the square wave. The square wave, you don't even understand this is a square wave. So yeah, for the square wave, let me just try to understand this is a square wave. You can take it to the maximum of, I would say, 50 kilohertz to the maximum. 50, it's the maximum for me. But okay, this is for low bandwidth. So, well, in terms of bandwidth, I think that's it. Okay, let me just connect my charger in here. Yeah, you can see the light in here when charging. So this is the reset button, as I told you in the beginning. Yeah, but in the screen nothing appears saying that it's charging. Anyway, it will do the job. I must say that this little stand, it's pretty cool for this device. It gives you a very nice watching position also. Okay, let's move on. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. So now it's teardown time. Okay, here we have the battery. It's a 10 milliamps hour battery. Let me disconnect here. Okay, so we have here the device. Let's continue to dismount this. Okay, it seems to be here. How do we take this out now? Okay, just a little pressure and we are on. I will now zoom this so we can have here a better view. Okay, so we have the board here. Let's start from this side. This is the old board. Let's start from this side. We have here expansion port or connection for a firmware update or something like that. I don't know. So in terms of processor, we have here the this manufacturer usually had only instructions in Chinese. It doesn't even care to have it in English, but right now we have for this processor instructions in English. So this is a Cortex M3 ARM compatible processor with RISC version 3A instructions. And let me see something more relevant. Yeah, basically this is an ARM processor. We have in here a little bit down 8 megahertz crystal. So yeah, let's move this out. On the left we have this ST084C. That's a general purpose GFET with quad operational amplifiers. And let's move this around. We have this 74 HC451D. This is a NXT. It used to be Philips, but this is a NXT 8-channel analog multiplexer. The multiplexer. And what else do we have? Okay. If you saw my previous videos on these small oscilloscopes, the Teardown, this is a usual relay that we have there. So let me just give you the right description. This is a sub-miniature signal relay. It will withstand voltage up to 2500 volts. Pretty nice component. And what else do we have? The Cosmo. We have here in the corner the Cosmo Y240S, and this one is a high voltage photo MOS relay. So this one should be the one that filters the voltage entry from the probe. So let's move on. We have here the connector, also the reset button that was that I showed you while it was assembled, and also near here the battery connector. Let me change. It's a usual one, the TP4056. This is a 1 amp standard linear Li-ion battery charger with thermal regulation. This is a SOAP 8 format, and we have also the U6 that is not populated. What should be here? Interesting. And in terms of ICs that are worthy for mentioning, I think that's it. Okay, so let's put this all together again and wrap this up. To wrap it up, and I'll try to keep it short, this DSO152 in terms of function is exactly the same of the loved DSO150 that was highly recommended by me for students or hobbyists that want just a cheap and reliable scope to start learning about these devices. Now we have a better case, and the problem of not having a knob that was seen, for example, in models like the DSO138 Pro was almost solved with these new button light knobs on the top. On the DSO138 Pro, it was a bit harder to navigate and use due to the lack of a knob-like button like this has, and this DSO152 is also firmware upgradable, so 2 extra points for this one. In terms of price, at €22 or about $23 for the version with only the alligator clips is actually cheaper than the DSO150. And if you want a probe and a MCX adapter with it, you will have to pay just more €2 or like $3 for my American friends. But let's consider the version with everything included. It is priced at €25 or around $27, which is a fair price for the device and quality you will get. I saw the DSO138, not the Pro version, at a much lower quality device for almost that price. In terms of bandwidth, I mentioned for several times during these small oscilloscopes reviews 200 kilohertz, it's really something that should be increased. It's too low for the current days and the device we have to test. That said, I still keep my opinion that if you want to start in electronics, don't want to spare a lot of money in equipment and want to test and know how an oscilloscope works, this device is perfect, even for professional usage where you'll not need bandwidths over 200 kHz. So if you are interested in trying this device and you think that my video is worth it, please don't forget to use the product affiliate link in the description or even the channel access affiliate links on the screen for your purchases. Same price to you, but a big help for the channel. And if you learned anything at all and this video was useful to you, please spread the love and slap that like button. And if you want to be one of the first to be notified when I upload a new video, just hit that bell and activate all notifications. That's it for today. I hope to see you in my next video. Thanks for watching.